This is problem 47 from chapter 14. Escalator steps move with a constant speed of 0.6 meters per second. If the steps are 125 millimeters high and 250 millimeters in length, determine the power of a motor needed to lift an average mass of 150 kilograms per step. There are 32 steps. So what we can do with that information for the mass is to find the total mass. So if there are 32 steps and you have 150 kilograms on each step, then you have 150 times 32 kilograms total, and that is 4,800 kilograms. We're going to use equation 1410. So we have power is equal to force dotted with velocity. And it might help us if we turn and look at problem 59, which happens to be the same as problem 47, but for problem 59, they give us a diagram. So you can see here they have the dimensions of the step. Oh, good thing we looked at that, because I didn't interpret that correctly. 250 meters in length means from front to back. Okay, and then we have the velocity here, and we could have figured out this height on our own without the diagram. I don't even know that we need the height, but that should be 125 times 32 to give us the total height, which would give us 4,000 millimeters, which is 4 meters. So that looks good. I guess the next step would be to draw a free body diagram. So you have the normal force that the step exerts on the mass, and you have the force of gravity acting downwards. And your velocity, well, you can see the direction from this diagram here, so that is helpful. If you want to do the dot product, you want the vertical component of the velocity. So let's draw a picture here, like this. If you look at a point here, sometime later, that point's going to be there. And let's blow this up a little bit, because the length of the step is 250 millimeters. This side has a length of 250, and this side has a length of 125. And whatever angle theta we have here, the velocity is going to be at that same angle. I can find that angle by saying theta is equal to the inverse tangent of 125 divided by 250. And that gives me 26.57 degrees. So now I can use that to say, well, actually, I could just do this. The power is equal to the force. The force is equal to m times g. And the total mass is 48,000 kilograms. So the elevator is lifting a total mass of 48,000 kilograms. A total mass, but then the force would be that times 9.81 meters per second squared. Okay, so this is the force dotted with a velocity. So how was I going to do this? I could say the y component of the velocity is v times sine theta. I guess that's what I want to do, because otherwise the other thing that I could do is say if this angle is equal to 26.57, this angle would be equal to 90 degrees minus 26.57 degrees, and then I could do the force and the velocity of 0.6 meters per second. And then I could either say cosine of 90 minus 26.57 degrees when I do the dot product here, or I could first find the vertical component of the velocity, which would be 0.6 meters per second times sine of 26.57 degrees, and then since that's pointing in the same direction as the normal force, since the vertical component of the velocity is pointing in the same direction as the normal force, I could just say my dot product is the magnitude of the force times the vertical component of the velocity. But since sine of 26.57 degrees is equal to cosine of 90 minus 26.57 degrees, it doesn't matter which way you do it. In either case, you will get 12,600 kilograms times, kilograms times meters per second squared. That's a Newton times a meter per second. So that would be a Newton times a meter is a joule. And a joule per second is a watt. So that would be 12,600 watts or 12.6 kilowatts.